So today we're going to present you two use cases that we did at Bell. And the first one is how we transform a legacy application into a modern way.
So I guess most of you know Bell Canada. So Bell Canada is a large service provider, and we have a lot of services. I mean, a lot of service, a lot of product. Some example like fiber internet, television, they acquire Bell Media, such mobility, all those kind of service. But one particular service that I'd like to focus on today is managed services. So what managed services is, basically it's a service where a large customer, come and see and ask Bell to monitor, manage the life cycle of their equipment, and it could be on any kind of equipment. I mean, it could be security devices, network devices, servers. So basically, we take care of their network, their existing network. We connect to that network, and we offer services on it. So one application that we use to do this managed services is a data collector, an SNMP data collector, let's say. So let's say I want to provide report to that customer. I want to poll those devices. I will collect metrics on interfaces, CPU. I will be alerting. So to do that, I need a data collector. We use we partner with Computer Associates (CA) for that. And I'm not saying the actual process, but the process that we were following before this migration, it took like a month. Let's say the customer was signing a contract with Bell and says, okay, start managing my network. It took a month to have all the tools set in place to start collecting data on that customer. And of course, it took a month before getting paid from that customer. So why it took a month is because everything was manual. I mean, we had to provision VM. We had to take care of the licensing. We had all the IP address assignment, firewall rules. Yes, we were really filling up an Excel file. We were creating an internal service request, sending that the service request to another group, because every unit, every team is working in silo. I mean, it's like that, and most of large companies. So there's a networking team, security team, app team. So yeah, so this is why we end up with this month of process to have this collector.
So we wanted to go to that process, to an automation process, and be able to deliver in one day. And from the installation, the configuration, the CMDB update, and also the backup system. What drives really this use case is when we decide to migrate to this CA application, we needed to spin 150 VMs in 2 data centers, and all this hardware only for a small application. So we decided we need a new solution, and by doing that, we also decrease a lot of the management at the OS level, the VMware team, the firewall team, and we wanted to increase the ops efficiency, the operation team, to simplify the installation, to also cut down a lot of the documentation, because it was hard to maintain with the new version and all the setup. And we wanted to deliver the service faster. One also of the challenge was also to simplify the MTTR on the software update, because with a lot of large clients, you cannot update when you want. We need to schedule maintenance window. We have freeze. We have a lot of challenge of trying to keep the platform at the same level on every client, which was simplifying our life with the container platform. And we wanted to simplify the client integration and have a unified solution. So our target was the client ordered a service, we are processing it, we are deploying it, and we are delivering the service, all that in one day.
So yeah, we're gonna jump right away to the live demo, just to prove that we're not lying. So what I'll try to achieve now is onboarding 2 customers, and then we'll continue talking about the benefits of that. It should take a few minutes. We're gonna have 2 data collectors in place. We're gonna pull 2 different customers. So let me just jump into that. So first of all, this is the console, the CA console. As you see, this really nice UI. Yeah. Well, even with the font size, I cannot. Okay. I was not expected that resolution issue. Okay, like that. Cannot believe it. Seriously. Okay. So those are 2. This is the console basically of a CAPM, and I have only 2 items. So I don't have any data collector yet there. What I'm gonna do, I'm gonna use OpenShift to provision those data collectors. So just a refresh issue like that.
So basically, while you are trying to starting, we wanted our people, the ops team, to be less skills to install that application, because before it was our level 3, which is highly skilled people that were doing that, because it was so complex that the level of mistake was high. So we needed to simplify this, so like a level 1 could deploy this application with only like filling some information, like you just saw that Martin did.
But again, I don't know this software at all. The only thing I know is OpenShift, but I don't know how this software works. And the only thing I had to do is just, like she said, fill the form. And here you see the deployment that is starting. So I'm going to start the other customer, just following the same process. The main difference will be the customer B instead of A, like that. And this magic IP that we will talk about later. Just like that. So it's actually the collector is installing itself. Yep. And we can just move back to the presentation.
It gets provisioning, installing, and configure all in the background. So while it's doing that, we can continue. So the benefit of doing that is we reduce a lot of our costs by reducing the infrastructure. At first, it was supposed to be 150 VMs, and we moved it to a OpenShift container. So we have that much of container, but only one version to maintain and one OS to maintain. It's the container itself that we need to maintain the image. So everybody has the same version, everybody has the same configuration. So if there is a problem, everybody is having it, so we can fix it really fast and deploy it really fast. So at a management level, it's a lot of saving costs on this. And I can continue. For the time, we reduce the time delivery, like you saw, in a few clicks, few minutes, and everything is automated on the background. So the network integration, and with the only thing that you saw that we put is an IP address. On the support level, since we don't have a lot of application and OS to manage, we cut down the support time to really a small window. Now we have a unified solution. It's so easy to upgrade that and deploy that we can do it in a heartbeat. And we also reduce a lot of the client integration complexity because everybody has the same solution. For the service, before it was maybe taking 4 hours to get the application upgrade, and or it could take 8 hours if there was an issue. We need to engage the server team to do the backup, and if something goes wrong, to restore and everything. So now we have just a rollback in a few clicks, and we have a better stability because, like I said earlier, everybody is running the same image.
And maybe to add on this, for the service, the maintenance window stuff, I mean, let's say the application is running on a traditional VM, and we have to patch this VM. So traditionally, we will have to install a patch and reboot that VM. So there will be an impact on that service. So we'll stop monitoring data, so that they will create a hole into the report. So now, since we are moving into containers, if we have to upgrade a node, well, it's out of the box. I mean, the pod would just be migrated to another. It would be rescheduled on a different node, so there will not be any impact on that service.
You said the network was a big challenge.
Yep.
Firewalls. So your solution also included the network firewall and all of that automation.
I have, yeah. If I have a slide on that, I will show you in detail how we manage the networking, how we integrate this OpenShift cluster with the networking gears that are in our management LAN. And you're right, it's really complex because we have to connect to every single customers, and we have to create isolation between those customers. So we'll go in deep on that later, if I may.
We start as a waterfall team and in silo, which has the server team, the network team, and all of those teams have their own processes. Sometimes we were waterfall with one team and the other was agile, and so that was a migration of the way we work. So at the end, we end up with a DevOps team, and we are deploying always in microservices, new services right now. So every time that we have a new service that we are doing it in that model, which means that the dev and the ops are working together. It's in container. Everything is developed in container, and it's running in a cloud OpenShift on-prem. So this is how we do it.
It's been a journey. So how we do the CI/CD at Bell? It's we have a development team. Most of the new development team that are popping up, if I can say, at Bell, they kind of follow this new wheel. That basically they are really following the agile process with a story. We have a Git repository. We have a code review process, a peer review process, and all the process from the dev, the lab to the production is 100% automated. It's all pipeline. Some of the team, and here you see that pipeline. We're using Bamboo, but me and on another project I'm using GitLab. Other are using Jenkins. So we have plenty of different tools, but at the end, we're all following the same CI/CD wheel for automation. And
Also,
even you were going maybe to focus on the Kubernetes stuff.
Yeah, I was going to say that even if it's not development, just application installation, we are following the same process of keeping our config into Git. Even if it's an application, the source of the binary, and also the how to deploy it. So we are trying to keep that same working wheel for every deployment that we do. And as you can see, we were when we did this wheel, we were starting our journey, and we were running Docker and Kubernetes and not OpenShift. So we did install this in our lab, and after a while, this journey, we decided that it was too much of a time to maintain that platform up to date, security and RBAC and everything that goes with this infrastructure. So this is why we start looking for a platform that was really fitting all our needs, because we wanted to spend time serve the client with new automation and also new feature and not maintain that platform.
So this is why we moved from Kubernetes to OpenShift.
One of the things about that architecture is before container, we were doing VMs in one data center and the other for the high availability or for the DR, disaster recovery. So we wanted to have our platform of container having the same high availability to a location, but on-prem. You can see in that slide that it's really high level, but that every data center has a way to connect to the client, and the secondary data center the same. So we wanted our application to be able to move from one data center to the second data center without nobody noticing it. So we did a stretch cluster of OpenShift into 2 data centers. So later we'll have more this in detail.
So back to the live demo, and now we hope that this collector is back online. So I'm gonna refresh this page, and you see here customer A, which is it says collecting data, and if I can just go, you see both collector, client A, and I point my screen, but client A and client B. With 2 different, well, those was the IP that I've put in the form in OpenShift. So those are ready to collect data. So then my customer is onboarded. So the month, this thing took a month before. No.
And I want to add that because it's our lab, so there is only one monitor device, but in the real production, our CMDB has every customer device, and if it's tagged to be cap and per for capacity performance, it gets seeded by an automatic system to that system. So at some point in 5 minutes, that system will populate the monitor device that this collector should monitor. So it's automatic.
Yeah. And from that collector, what we will test if we have SNMP reachability to few devices. In this lab, I have 4 routers. Those are CSR 1000V from Cisco, just for testing purpose. So those I have 2 routers with SNMP enabled on it. So what I'm gonna do, I'm gonna try from that pod. I'm gonna execute an SNMP walk command that I have in this.
So one of the challenges that we had was to every client has the same IP. So they all use internal IP network, so the 10 dot something or the 192. So we have overlapping IP in every client. So we needed a way to be able to reach those devices on their real IP, even if they're on the same. So
yeah. So I'm gonna try to reach 10.1.1.101 for the customer A. I got it. So you see the router name here, customer A router 1. Let me move on another project, another namespace, which is my customer B. It's 2 different customer, 2 different project. I should have a pod here. So here's my pod. I will execute the same command on that pod. I'm going to reach my second customer with the same IP, 10.1.1.101. And you see that the router name is customer B. If you are asking yourself why we are doing this and why we are focusing on that, if I recall the start of that session, I was saying that managed services is we connect to an existing network. So the customer has already a network, and we have to connect to that network and manage their internal switches. So there are big chances that they're all private IPs assigned to those switches. What if I try to connect to your home? Who has 192, 168, 2.something at home? How can I connect to all of those? I need this platform. We'll go in detail on the how we've done that. It's a twist.
So to find this solution, actually, we partner with Arctic team, which is a Red Hat partner, because when we started the project, we had an idea and we didn't know how to achieve it. We said, this is what we want to do, but we don't know how to do it yet. So we partner with that team, and then we find a solution, which we'll talk later a bit.
Yeah, exactly. So, so before going into this detail, I'm gonna present you a second use case. So the first use case was clear. I mean, it's about monitoring devices. The second use case is about doing configuration change on those devices, because the customer will make requests to Bell, will send requests to Bell and says, okay, can you configure the interface of that router? Can you configure the OSPF on that router, or a switch or whatever? So the way it's done today, and it's still like that, we are trying to change that, but it's all manual. The customer is writing a request, so okay, I'd like this configuration to be applied there and there. He sends the request, then there's an agent, a junior that takes the request, then he pushes the request to a senior to have the full configuration. The one that were in the previous session, for Ansible, they were talking about MOP, method of procedure. So it's basically what they are doing. So the senior technician is preparing the change, put it back into a ticketing system, and then the technician will take that configuration, will log into the device using CLI, will apply the configuration. It's been like that for
30 years.
Forever. Forever. So it's all manual. What we are trying to achieve, not saying that we're there yet, what we'd like to is have a client request, we test the configuration, and we release it. As simple as that, and all automated. We don't want a technician that will log at 2 in the morning just to apply a change on a switch. So
So like we said, the business driver was to automate 3,000 MACD a year. So they were all done in the manual process with the L2, L1, L3 people, and the error percentage, we don't know how much it was, but at some point we know that if we automate and test the configuration, it will decrease a lot. We don't have a percentage yet because we don't have a year of data, but at some point when we'll have the data a year later, we'll be able to put a number on that. And it was cutting down an hour per MACD, so meaning that we are saving 3,000 hours of work over a year, so it's a lot of money to save. So also we reduce the software license because we were using a software called HPNA, and it's really expensive when you are a service provider to use that kind of software because the licensing model doesn't really fit a service provider. So
yeah, it's because it's per device. So the more device I manage, the more the cost of licenses. So it doesn't really make sense for us as in that business. So yeah, so we estimate that we could reduce an hour per MACD, 1,000 MACD per year. So it's a lot. So I have another demo. This demo is a tool that I've created. It's a proof of concept, and it's funny because I didn't know about the previous session about Ansible, and you'll see I'll do almost the same thing as what they've done with Ansible. But through that tool, it's really to give us a very simple interface to the operation. And also, the other reason why I went with a custom tool instead of, let's say, Ansible Tower or Ansible YAML playbook, this is because every change, every request is different. I'm not managing a data center with a fixed configuration or with an evolving configuration. I'm doing a configuration change on that customer and that router and this router. So I cannot have. I will need 20,000 playbook to do that. So that was not really, that didn't really fit with our need. Yeah. So the tool. So this tool is basically a small UI that is all running on OpenShift, by the way. It's on another namespace. If I just go on.
Like I said
here,
before, everything that's new gets developed in a container, microservices architecture, and deploy in OpenShift.
Yeah, exactly, and it's pipelined. Even if it's a demo, it's all pipelined. So you see, it's a small tool like API server, database, Mongo, and a UI, JavaScript UI. Very simple setup. And the important thing here, it's running in a namespace common tools. It's isolated. And you'll see here why it's important. So let's see the list of hosts that, this is kind of my inventory that is loaded in that tool. The idea behind that tool is to use OpenShift, to leverage OpenShift as multi-threading and job scheduler. So instead of dealing with threading and stuff like that, I let OpenShift do that for me. So let's try to ping the first device. I'm going to click on that. You see, create a job. But in fact, in OpenShift, what it does, it creates a job. It creates a pod dynamically. And this pod has an image, which is runner2 ping. And it has a config, which is a config map. And this config says ping that IP, the same IP that we've reached earlier with the other tool.
So maybe we can add that because of the earlier session, this is all Ansible.
Of course. The image, you will see that I have multiple Docker images, and the way I've done it is it's Python script that are using the Ansible engine. I'm importing the library from Ansible, but I'm not using the Ansible playbook command with the YAML file. That's the only difference. But on the back scene, it's still Ansible engine. So so I've done a ping. And what if I click on all 3 devices at the same time? So I have 3 jobs being scheduled. I will see here all those pods on 2 different customers. You see the project B has 2 pods running, and project A has 1. Now it's completed. Running. It's gonna get through. Now they're all completed, and I have IP reachability to those routers. So now if I go on this router, I don't have any information. So I'm gonna execute the traditional getFAQ command. But again, if I click on this getFAQ button and I look at the pod, you see that the image now is different. It's not ping anymore. It's runner2 getFAQ. I don't know if you see on that screen, but it's runner2 getFAQ iOS. Runner2 getFAQ iOS is just, again, a Python script with the Ansible lib imported in it. And a config map that says, here's the device that you have to connect to. So once it's done, well, I can see some detail. And if I go through the log, you will recognize some output that are from Ansible. So let me go back to the host list. Now you see that I know the real host name of that device. And if I open this window, I got the interfaces status and the configuration of that device. So I'll do just like I've done for the ping. I'm going to gather the facts of all those devices. The good thing here is it's going to connect to all those devices simultaneously at the same time. And all of those are isolated in their namespace. So it's almost done. And then let me try to do a SNMP, because there's a module in Ansible which is SNMP, which is get fact SNMP. So get the fact through SNMP protocol. So I'm running this. You see here the job. Go back to the host. Oh, and it failed. The job failed. Why does it fail?
It's not because it's live demo.
No, it's not. It's not. No SNMP response received before timeout. So let's configure SNMP then. So I'll go to my activities, and for this customer, thankfully I had an activity to configure SNMP. So I'm gonna execute it on router 2. Let's take the SNMP category, and the screen is yeah. Let's do it like that. Okay. Thanks for the responsive design. SNMP configuration. So you see that by taking a template. So the goal of that tool, the idea behind is. Let's say I have my senior network operator. So they're gonna build templates. They're gonna say, hey, my customer A, because they are all senior per customer. They have pool of customers. Hey, this customer, I want this SNMP template to be applied. This customer, I want that template. So the technician will just basically take that template and will fill the question. So in that case, it asks for a community. So we'll accept it, create a job, start a job, and guess what? It's gonna spawn. Oh, it's customer B. It's gonna spawn a new container. Just the same way. Just the same way I've pinged a device, the same way I've SNMP it. When I configure it, I'm just following the same process. So it's easy to troubleshoot. And so here's, sorry for the, yeah, so runner 2 configure iOS, so it's a different image. And yeah, so if I look at the config map, we will see that this config map contains the configuration that needs to be applied. So it's really about leveraging OpenShift again as a scheduler engine.
So this is a demo, but when we have sensitive information, we put it in secrets in Kubernetes. So you wouldn't see the information that we put in that like this. So that would be kept.
Did I show the password?
That's demo in lab. So.
Okay. So now SNMP is on. So I got some more detail on that device because some detail that was not available through the get fact, so through SNMP. The final thing I'd like to show you about this tool, let's connect to those two routers from that customer A. The IP you see, actually it's out of band IP. I had to cheat a little bit, sorry.
And it wasn't arranged with the Ansible team earlier that show how to configure OSPF. Yeah, so the goal here will be to configure OSPF, so just in the same mind thing. It's funny, it's really funny. Show OSPF. I don't have any OSPF config in both cases. Let's look at the interfaces. So the interface 3, which is the interface that I'll use for OSPF, is not configured. So what I'll do is, again, taking this, using this tool to configure, you see the last activity here on customer A. I want to configure OSPF between router 1 and 2. Which is more the use case that we want to
Yeah.
achieve in real life of managed services.
Exactly, in the real world, it's just like that. So I'm going to select, well, I'm going to select first an interface. I'm going to pick this interface, and I'm going to associate this. This interface will be a NoSPF interface. And the router ID, you see the template that was available? I'm going to put the router ID 1. Let's say, accept. Then for this router, the same router, I need an OSPF configuration. So a router, in the router category. So for that OSPF router, it's still router ID 1. So same thing for router 2, interface, 3. I'm going to select the OSPF interface again, not the same router ID, 2. And router 2. So I'm going to create a job. But maybe my customer don't want this job to be applied right now. He wants this job to be scheduled later on. We are changing his routing. Some customers don't want that in the daytime. So we can schedule that change. So for demo purposes, I will not schedule too late. So I'm going to try keeping, and with this resolution, it's terrible. Yeah, pod initializing. So you see this is the ID of, I can show you so you get the job. The relation between the hierarchy of all this. So this is the cron job that has generated this job. You see that this is the same. Let me.
Same ID.
Yeah. Like that. So you see the IDs. Okay. So this is the ID of the. Here's the ID of the job, and then it adds a little UID for the pod. And if I look at the pod again, it should be completed. I will go back in my UI. Looks like it went through. So I've configured router 1 and 2. Both jobs are successful. So I'll see if I'm lucky. And IP OSPF neighbor, let's see some detail. And it's up for 37 seconds. So OSPF is enabled between those routers. So it went through. So your question about the complex networking, what we use. When we work with Arctic, they came and see, why are you not using MAC VLAN? MAC VLAN is the ability to give to a pod a network interface that is associated to a host, associated to the external host interface. So it's a bridge, basically. So from my switch that is in front of my compute node, I can see the MAC address. I can see the MAC address of that pod. And from the firewall, which is in front of my nodes, I can see the IP, one particular IP, one dedicated IP per pod. And why it is important? Because again, can I route based on the destination? No, I cannot. I cannot because two customers might have the same IP addresses, right? So instead of that, to fix that, I will be routing based on a source. So if I'm coming, so I'm gonna put complex rules into the firewall. Actually, we're using the SRX JUNIPER firewall. So I'm gonna put complex rule that says, if you're coming from 100.64, that remember I've put this IP when I have instantiated the data collector, 164.0.5, then your customer A. So you're gonna use the routing table of customer A. And because it's two different routing tables here, A and B, I can have the same route in those routing tables. Those are dedicated per customer. So basically, when when I have instantiated a job, I just have assigned an IP to it, which is part of part in that case, part of a /27 subnet. And that subnet is, there's an action in JUNIPER that says that subnet use the routing table A. And the other subnet use the routing table B. Any question on that? Is it clear? Yeah. So it's good, it's working, and it's in production. Actually, this is what we are doing right now. But we still find that there's a lot of complexity. I mean, I still need to have a static IP address to my pods. I still need to manage that, and I'd like to find a way to avoid that. And one solution that came, and then we are in the process of testing, and unfortunately I cannot demo you right now, is JUNIPER CONTRAIL as a SDN solution. So JUNIPER CONTRAIL will give me the ability to run a vRouter, CONTRAIL vRouter, inside the OpenShift nodes. Meaning that I can bring the routing table of that customer up into the node. So I can attach the pods right to the right routing table. So I don't need this PBR stuff. I'm already in the right routing table. So from there, because I have that, I can route on the destination then, because I don't have any conflict anymore. I brought this routing table up to the customer.
So meaning the complexity of maintaining the range of IP by client will go away and will be much simpler.
So there's many SDN. CONTRAIL is one that we are really looking at, but we know that there are other like Calico and stuff like that, but it's under evaluation.
So like I said earlier, we start with Docker, Kubernetes, build, homemade build, and after that we decide to go to OpenShift, which is the closer match that we have since we were already Docker and Kubernetes. So after that, this is what we learned. So what we should and what you should not. It's first start by reading the best practice, even for Docker, Kubernetes, and OpenShift, because you'll learn a lot of things. And when you start and you don't have the knowledge, it's better to start with some guidelines than start with the white page. There is a best practice of creating a base image. So for us, for example, we are running by default on a RHEL image. So a lot of the Docker Hub, they'll run Alpine, they'll run many of other flavor, but after that, you'll realize that you need to convert them into more secure OS to run this in production. So start with a base image with the right package and updated and from RHEL, and understand really the basis of the security, OpenShift or Kubernetes. It's really important because when you go in production, and as like us, we manage big client, we need to have service accounts, we need to have secrets, we have to have roles and security policy, so we don't end up with a security hole or stuff like that. So at first, when you start with an image, you don't know all of this, but at some point you'll realize that if you really want to keep the same level of security that you had at first with a VM or bare metal, you want the same in your container. So it's a good thing to understand that from the get-go. And also the other thing is sometimes you relax the security in development, so it's easier for the developer and everything of that, but it finds out that you are losing time. At some point, you should run the same as your production. So every time you go from dev, test, staging, it's always the same security, same policy. So if it's working in dev, it will work in production. We suggest to don't relax the security because of a time constraint. Sometimes you say, oh, I'll do it later, I don't have time, I need to deliver fast. Yeah, you better take times at the first, and it's gonna be better.
Trust me, when I started designing this MACD automation tool, I didn't follow any of those rules. It's true. I was running Kubernetes, I was no security, And it took so much time to take this application and bring it in production. So I said, I will never do this again. So I'm right from the start, run an OpenShift, run security with a service account and all the best practice from the start in your lab. And then when you go in production, it will go just like that.
Maybe I'll add just another one that I forget, but it's important to have a champion in your team that knows this, because if you are trying to show this to everybody, it's going to take a lot of time. But if you have a champion to train the other or explain or help them, create a good base image or to help them integrate the service account, roles, and secrets, you have better chance of success.
Find your champion.
Yeah.
Thank you.
Thank you.